Plum Pudding Model was given to us by J.J. Thomson, and his major claim to fame, I guess you could say, is he proved the existence of the electron. Now, in reality, he was involved in a lot of things, like the existence of the proton, figuring out charges. J.J. Thomson got the Nobel Prize in 1906, I believe, and he was involved in a lot of the development of the theories, not just the Plum Pudding Model, but his student, Ernest Rutherford, went on to deal in the nuclear model. He was directly involved in so much of the work of the atom. We can't just limit him to the Plum Pudding Model. And the electron now was known and predicted by George Stoney long before J.J. Thomson proved it. But George Stoney couldn't prove it, or didn't prove it, and was responsible for even giving the name to the electron. J.J. Thomson actually originally called it a corpuscle, but eventually the name suggested by George Stoney in 1892 that we call it an electron when we discover it, or when we prove its existence, is what caught on. Today we call it the electron. J.J. Thomson proved his work with the electron, proved that it was a particle by working with Cathode Ray Tube. It was kind of the predecessor of the TV tube and our CRT monitors in the early days of computers. And here's a drawing of the cathode ray tube, and basically we had the cathode, negative electrode, and we had the anode, the positive electrode, and they just focused down the rays there and realized that these rays seemed to give off light when they hit the fluorescence on the end of the tube. Eugene Goldstein suggested that we call these cathode rays, since they seemed to come from the cathode. And so we called them the cathode rays. And cathode rays were determined to be electrons. And here's how J.J. Thomson did it. He took a positive magnetic source, and when he put a positive source near the electrodes, he would get rays would be attracted to the positive. And then when he put a negative force on there, they would be repelled. Now, I learned something when I was pretty young, and that is an important idea here that's going to be usable throughout your career in science. No matter how high you should go, where you should go, you should always remember this idea, and that is that opposites attract and likes repel. And he noticed that when he put the positive near the tube, it attracted the rays, and when he put a negative there, it repelled. And so that gave him pretty conclusive evidence, and even fairly direct evidence, that cathode rays were made up of a negative charge, and he believed it was a negative particle. And we call that an electron today. Now, notice that I have E there. E doesn't really stand for electron. It actually stands for charge, and so that means negative charge. Those of you who might be wondering about that, it really doesn't stand for electron. That just means negative charge. And of course, the negative charge applies to cathode rays, and today what we know as an electron. But he hadn't proved that it was an electron, or that it was a particle. In order for something to be a particle, there needed to be mass. And so if he could prove that there was a mass to the electron, then the electron would be a particle, and we would realize that the atom was not a solid sphere. Well, that leads us to the oil drop experiment. Robert Millikan performed the oil drop experiment. You can look that up or on the internet or Google Robert Millikan or oil drop experiment and read up on that. But he performed the oil drop experiment and determined the exact charge of the electron. Now this was important because by determining the exact charge of the electron, J.J. Thomson, who had already figured out the charge to mass ratio, could then mathematically take the charge to mass ratio and the charge of the electron, multiply them together, and get the electron mass. And he found it to be 9.109 times 10 to the negative 31 kilograms. Now that's a very, very small number. As a matter of fact, it's 1,836 times smaller than a hydrogen ion or a proton. Very small. And for our purposes, much of the time, we're going to just treat an electron as if it has no mass. But it actually does. It has an extremely, extremely small mass. So the Plum Pudding Model, as J.J. Thomson saw it, that there was this mass, this positive mass, that would be like the blob in plum pudding. And in this plum pudding were these embedded electrons in the positive material. And it would look like, or he thought it would look like, plum pudding. Now, I think he was probably influenced by the fact that he was British. Because I think if an American, or if in particular even a Texan, had realized or developed this idea, we wouldn't have called it plum pudding. I prefer to think of it as maybe banana pudding. But plum pudding is what he called it, and so we'll go with that. But I see it more as a plum pudding with little bananas in it instead of a banana pudding instead of plum pudding. That's my preference. All right. If you have any questions about the Plum Pudding Model, you can go to mrcausey.com, or you can send me an email, mrcausey@mrcausey.com.